Hello. We have Pre-Calc Lesson 56, triangular areas, areas of segments, and segments of inequalities. So triangular areas, just a reminder, we have a triangle here. Now the area of a triangle is 1/2 base times height. And we know that the definition of the height is that it is perpendicular to the base. This is really important because now we'll be given triangles where we don't know the height, but we know this angle over here. We will use this angle to find the height using trig functions. Okay, so grab another piece of paper. Can't reveal all the things at once. So here is your triangle. Okay, we are given two sides, 12 and 16, and one angle, 42. We need to find the height. We're trying to find the area of this triangle. So I draw my height here, and it's perpendicular to the base. And I know that I have the opposite and hypotenuse, so I can say that the sine of 42 is h over 12, meaning that h is 12 sine of 42, which gives me about 8.03 inches. So my area is 1/2 my base is 16 and my height is 8.03, giving me about 64.24 inches squared. Don't forget your units. Very, very important. Okay, let's go to this triangle. Okay, now let me redraw it for you. I think that's a little confusing. We're given this is 150, this is 6, and this height here is 14. Now we can't draw our height this way, but I can draw it here, create a right angle there, make this my height. I know that this is 30. Okay, so now you're caught up on where my triangle is. Okay, and I can again solve for my height using the sine function. I can say that the sine of 30 is height over 14. So my height is 14 sine of 30, which is about 7 meters. So I can find my area by doing 1/2 base times height, which gives me 21 meters squared. Okay. Now, we can also use this for a trapezoid. If I'm given this trapezoid here, I can draw my height because I know that the area of a trapezoid is 1/2 base times height. Okay, and I can find my height by using the sine function again. The sine of 29 is h over 5. So h is 5 sine of 29, which gives me about 2.42. Then I can say the area of my trapezoid is 1/2 base 1 plus base 2, which is 10 plus 4, times my height, which gives me about 16.94. Don't forget your units. All right, now let's talk about area of segments. We're going to use that knowledge of area of triangles to find the area of our segments. Now we've talked before about the sector of a circle. We talked about this last year. Sector, or a piece of pie, is the area bounded by two radii and an arc. So here are your two radii, here's your arc, and this angle here is the central angle. Now, we remember that the area of a sector is the central angle over 360 times pi r squared. You can also do the central angle over 2 pi times pi r squared. Just depends on if you're in degrees or in radians. Now, the segment of a circle is if we have a sector and this line that cuts the sector, it's the shaded portion here. Okay, and how we find the segment of a circle is we do the area of a sector minus the area of a triangle. Now, to find the area of the triangle, we have to find our height, which we're going to use the same way we just did with triangles. So, find the area of a segment if its central angle is 0.6 radians and its radius is 10 feet. So, you always draw a picture first. So here is my triangle, here's my sector, 0.6 radians, and my radius is 10. This is what I'm looking for. Now, my height I draw here, and I'm going to do the sine of 0.6 is h over 10. Now, you need to be careful that your calculator is in radian mode. If it's not, you will get this wrong. You have to switch it from degrees to radian mode. Okay, so I find my height by doing the sine of 0.6 radians is h over 10. So h is 10 sine of 0.6. Then I know that the area of my segment is the area of my sector minus the area of my triangle. The area of my sector is 0.6 over 2 pi times pi r squared minus the area of my triangle is 1/2 base times height. And if I simplify it and solve it out, it gives me about 1.75 feet squared. That's the area of a segment. You need to remember the area of a sector, so maybe you should put that in your formula sheet. All right, now let's talk about graphs of an equation. The graph of an equation divides the plane, the coordinate plane that we're graphing on, into 3 disjoint subsets. It divides it into points that lie on the graph, points that lie above the graph, or points that lie below. The bottom 2 satisfy an inequality. What we're going to be doing is we're going to be given an inequality, okay, and we are going to find the region that satisfies it. Now, this next example, I'm going to give away the answer right away, okay? So, we have these 2 equations. Y is greater than or equal to 1/2 x minus 4, and y is greater than or equal to negative x squared plus 4x. You will be given this graph minus the shading. Okay, later on we will do these problems where we will graph it ourselves, but for now you are spoiled. You are given the graph, and you are given these regions A, B, C, and D, and you want to know which of these regions satisfies both of these inequalities. Now we're greater than or equal to our line right here, 1/2 x minus 4, which tells me we're going to be above the line, and we're greater than or equal to negative x squared plus 4x minus 1, which means I'm above my parabola, which is why I shaded this area here. Now I need to pick a point in that region. I picked 0, 0, to make sure it satisfies both of my inequalities. You have to check this point. I am grading that, okay? On your quizzes and tests, when you do this, you have to check a point. That is part of your grade, okay? So the point I choose is 0, 0. I plug it into both of these inequalities. 0 is greater than or equal to 1/2 times 0 minus 4, which gives me 0 is greater than or equal to negative 4. That is true. Okay, then I do 0 is greater than or equal to negative 0 squared plus 4 times 0 minus 1. So 0 is greater than or equal to negative 1. Also true, which tells me that A is the correct region. Let's do another example. Okay, you're given these 2 inequalities. X squared plus y squared is less than or equal to 16, which is this circle, and y is greater than or equal to x, which is this line. Now, since we're less than or equal to the radius, I know we're going to be inside of the circle, and greater than or equal to x, I know we're going to be above this line. So I think it's region B. I need to pick a point in region B. I picked this point 0, 2 to see if it satisfies both of my inequalities. So if I plug in 0 squared plus 2 squared is less than or equal to 16, is 4 less than or equal to 16? Yes, that is true. It satisfies one of my inequalities. I need to check my next inequality. Is 2 greater than or equal to 0? Yes. Therefore, I have picked the right segment, and that's my answer, is segment A. I'm sorry, segment B. Okay? So remember, you need to check a point. If you don't, you will not get points for it. Okay, that is part of the points that you are receiving. So make sure you check a point. As I said, later we will be doing this a little more complexly. But for now, you're given the graph and life is hunky-dory. So you may be hunky-dory on the rest of your homework.